Imagine a disease, highly contagious, affecting animals. It's invisible, sort of lurking, until, bam, it explodes. Suddenly farms are threatened, food supplies too, even wildlife gets hit. That's basically the shadow cast by foot and mouth disease. FMD.
It's a global problem, yeah.
Yeah.
Highly contagious, viral, affects cloven-hoofed animals mainly.
And it's caused by this tiny RNA virus, FMDV. Comes in what, 7 types?
7 distinct serotypes, yeah. OA, C, the SATs, 1, 2, 3, and Asia 1, plus over 60 subtypes.
And here's the kicker, right? Getting sick with one.
Offers zero protection against the others. None.
Which explains why it spreads so fast.
Yeah.
The economic damage is huge. We're talking billions, trade embargoes.
Devastating, truly.
So in this deep dive, we want to unpack something specific, the really different roles of 2 animal families. Camelidae, that's camels, llamas, alpacas,
Right.
and Cervidae, the deer species. How they interact with FMD, it's completely different.
Night and day, almost.
And understanding why is, well, it's crucial for global animal health.
Okay, let's unpack this often misunderstood disease. See how these families sort of defy expectations. But before we get to the animals, maybe quickly set the stage on the virus itself. What makes FMDV such a persistent threat?
Well, its nature as an RNA virus is key. It's just incredibly prone to mutation.
Like it's constantly changing its disguise.
Exactly. Its replication machinery, it's kind of sloppy. It doesn't have the proofreading function some other viruses do.
Okay.
So you get this high mutation rate. New antigenic variants are constantly emerging.
Which makes controlling it really difficult.
Extremely difficult. It means you need constant surveillance, always checking if the vaccines match the strains actually circulating out there. Like serotype O is the most common one globally right now, but serotype C hasn't been seen since 2004.
Wow. So it might actually be gone outside of labs, maybe.
Possibly, yeah. Effectively extinct in the wild, perhaps.
And how does it spread? What are the main routes? Primarily direct contact. Saliva, nasal secretions, feces, milk, semen from infected animals.
Okay.
But it's also really good at indirect spread, fomites, we call them.
Contaminated stuff.
Yeah, equipment, vehicles, clothes, people moving between farms, and then there's airborne transmission.
Right, especially when it's cool and damp.
Precisely. It can travel pretty far through the air then. But maybe the most insidious part.
What's that?
Animals can shed the virus for up to 4 days before they show any signs.
Oh, wow. So it's spreading silently.
Exactly. Silent transmission makes catching an outbreak early incredibly hard.
And once it's in the animal, what happens?
Well, it usually gets in through breathing, eating, or mucous membranes. First, it replicates in the throat area, the oropharynx.
Okay.
Then it gets into the bloodstream, spreads to the mouth, feet, mammary glands, causes those typical fluid-filled blisters, vesicle.
The ones that burst and look really painful.
Yeah, they rupture into these painful erosions.
That sounds incredibly debilitating.
Yeah.
Causes lameness, trouble eating.
It really does, which, just makes everything worse for the animal.
Okay, so that's the virus. Now let's turn to our first family, Camelidae. Camels, llamas, alpacas. You might think, given FMD affects cloven-hoofed animals, they'd be major players. But you said their story is more nuanced.
That's exactly right. And it's so important not to generalize across this family. Susceptibility, their role in spreading the disease, it varies profoundly between the different species.
Okay, so break it down for us. Old world camels first.
Right. Let's start with Bactrian camels, the 2 humped ones. They're susceptible. The World Organization for Animal Health considers them epidemiologically significant.
Meaning they can get it and spread it?
Yes. Natural infections happen. Experimental studies confirm it. They tend to show moderate to severe signs, mostly on their back feet, actually, causing bad lameness.
When does that show up?
Usually about, 8 to 14 days after they're infected. They get viremia virus in the blood and develop high antibody levels. It's a productive infection.
Okay, so Bactrians are definitely susceptible, but I feel like there's a but coming for dromedaries, the one-humped camels.
Oh, absolutely. This is where it gets really interesting. Dromedaries. They are remarkably resistant to natural infection.
Resistant how?
Experimental studies, even when they hit them with high doses of the virus, no clinical signs, no viremia. They don't even seroconvert, meaning no antibodies show up.
Wow.
And field studies back this up. There was one in Oman, dromedaries living right alongside infected cattle and goats. No sign of infection in the camels. Suggests a really strong, innate resistance.
But I'm sure I've heard reports, field surveys finding antibodies in dromedaries. What's happening there?
That's a great point. It leads to what some call serological noise. You do see some field surveys, mainly in areas where FMD is common, reporting maybe 10–15% of dromedaries having antibodies against the virus's non-structural proteins, NSPs.
And NSP antibodies mean the virus replicated, right?
They suggest some level of viral replication, yes. But the consensus now is that dromedaries likely only experience what we call abortive or subclinical infections. Meaning the virus might replicate just a tiny bit, enough to trigger that antibody response you see sometimes, but not enough to cause actual disease, not enough for anemia, and crucially, not enough to be transmitted onward.
So they aren't really a risk for spreading FMD.
Exactly. They don't seem to pose a significant risk. But that serological noise, it can definitely complicate how you interpret surveillance results if you're not aware of this nuance.
Okay, that's old world camels. What about the new world ones? Llamas, alpacas?
Even less susceptible. They're generally considered epidemiologically irrelevant.
Really?
Yeah, they're quite resistant to natural exposure. If you do manage to infect them, maybe by direct injection or really intense co-housing, the signs are very mild and short-lived. Maybe a slight fever off their food for a day, some minor sores on their foot pads. Oral lesions are really rare.
And the really critical difference here for all camelids.
The absolutely crucial point is this. No camelid species has ever been shown to develop the FMDV carrier state.
They don't hang on to the virus long term.
Nope. Even in llamas that get experimentally infected, the virus is cleared fast, usually within about 2 weeks. They don't transmit it effectively. They basically act as dead-end hosts.
Meaning the virus hits them, maybe causes a mild issue or nothing at all, and then just stops.
Precisely. They don't play any meaningful role in keeping an outbreak going or maintaining the virus in a population.
So if I'm getting this right, while technically some can get infected, especially bacterians, overall, camelids, particularly dromedaries and the New World ones, they are the animals driving FMD spread. They aren't keeping outbreaks alive.
You've got it. That innate resistance, the rapid viral clearance, it makes them fundamentally different from other animals susceptible to FMD when you're thinking about long-term disease dynamics and control. That lack of a carrier state is key.
Okay, fascinating. Now let's flip the coin, the Cervidae family. Deer, elk, moose. If camelids are the surprisingly resistant ones, what role do deer play?
Here we have a stark contrast. All cervid species are considered uniformly susceptible and, importantly, epidemiologically significant.
Why significant?
Well, think about it. They're often widespread, can have high population densities, and frequently live right near or even mix with agricultural areas. That creates a really high-risk interface between wildlife and livestock.
And they don't just get mildly sick, like the llamas.
No, not at all. Cervids can suffer severe clinical outcomes. They get the classic acute FMD.
Fever, drooling.
Yep, fever, lots of salivation, nasal discharge, they don't want to move, and those characteristic blisters and sores on the tongue, lips, gums, between the toes.
Causing lameness, making it hard to eat.
Exactly. Weight loss is common, secondary bacterial infections too. FMD can be a major cause of sickness and even death in deer populations.
Really? Death?
Oh, yes. One experimental study in white-tailed deer, exposure to FMDV led to 40% mortality.
40%.
And another study, this time in mule deer, showed really severe disease. High rates of myocarditis, inflammation of the heart muscle, which led to high mortality as well.
Wow. Okay, so they get really sick. What about spreading it?
They're efficient shedders of infectious virus. Experiments confirm they can transmit it easily to other deer. And critically...
Let me guess. From cattle to deer and deer back to cattle.
You got it. Transmission from deer back to cattle is well documented.
Okay, that brings us to the big question, doesn't it? The most critical difference between deer and camels regarding FMD.
It absolutely does. And the answer is the carrier state.
Unlike camelids, deer can become carriers.
Yes. Cervids can become persistent carriers of FMDV. Studies have found viral RNA in white-tailed deer as long as 11 weeks after they were first infected.
11 weeks, so even after they look recovered.
They can still be harboring the virus subclinically. This means they act as true reservoir hosts.
Keeping the virus alive in the wild population.
Exactly. And potentially reintroducing it to livestock, completely undermining eradication efforts.
Has this actually happened? Spill over into deer, causing major problems.
It certainly has. The classic example is the 1924 FMD outbreak in California.
What happened there?
The virus spread from livestock into the local mule deer population. Realizing they now had a wildlife reservoir, authorities launched this massive and very controversial eradication campaign.
Oh, massive.
They ended up culling over 22,000 deer, just to try and stamp out the virus in wildlife and protect the livestock industry.
Wow, that's intense. Any more recent examples?
Yeah, unfortunately. Outbreaks in Israel in 2021 and in a wildlife park in Pakistan that same year also involved spillover into local wildlife populations.
So it's not just that deer get sick. It's that they can hold onto the virus. They can be this hidden pool of infection that could restart an outbreak in livestock even after you think it's contained. That's a huge challenge for control, right?
Absolutely. It's a complete game changer. And if you think about the bigger picture, vast, dense deer populations, especially in places that are currently FMD-free, like North America.
It changes the whole risk calculation.
Fundamentally, an FMD outbreak getting into those populations wouldn't just be a livestock emergency anymore. It would likely become this massive, drawn-out, landscape-level epizootic, an animal disease outbreak across a huge area.
So what does all this mean for how we actually manage FMD globally? This huge difference between camels and deer. It must have massive implications for policy, for control strategies.
The implications are enormous, economically, policy-wise. An FMD outbreak that gets into wildlife like deer, it's a multi-billion-dollar disaster waiting to happen.
More than just a livestock outbreak.
Way more. Remember the 2001 UK outbreak? That didn't have significant wildlife involvement, and it still cost something like £8 billion. Now add a deer reservoir into the mix. Costs just explode.
Right.
You're looking at much longer outbreaks, needing huge geographical restrictions, incredibly complex and lengthy processes to prove you're free of the disease again.
Longer trade embargoes.
Extended embargoes, yeah. Maybe even permanent loss of some export markets.
And it's not just farming, is it? If it's in wildlife.
Exactly. It devastates other sectors, too. Hunting, tourism, the whole rural economy takes a hit.
Which creates conflict, I imagine. Eradication might mean culling wildlife.
Precisely. You get this major conflict between agricultural needs, potentially large-scale wildlife culling, and public desire to protect wildlife. That conflict itself can seriously hinder how effectively you can respond.
So does this mean the old way of dealing with FMD, stamping out quick eradication, might not even work if deer are involved?
It could become ineffective, yes, especially in regions with large established deer populations. If the virus gets truly established in wildlife, you might be forced to shift strategy.
From emergency response to
more of a long-term endemic disease management approach. That would mean things like sustained livestock vaccination programs, continuous wildlife surveillance.
And maybe even changing international trade rules, redefining FMD free.
It could necessitate a renegotiation of those standards, yeah. Distinguishing between FMD-controlled regions versus truly FMD-free, it's a massive strategic shift.
So how should surveillance and biosecurity adapt, knowing this difference?
For cervids, wildlife surveillance has to be a core part of contingency planning. Proactive, not reactive. Especially in FMD-free countries that have large deer populations.
And for farms?
Biosecurity needs to explicitly include strategies to minimize contact between livestock and deer. Things like double fencing pastures, making sure feed and water sources are secure, maybe even managing habitat near farms to make it less attractive to deer.
Okay. And for camelids, surveillance looks different.
Much more targeted. Given their low risk, routine surveillance for dromedaries, llamas, alpacas generally isn't necessary. You'd focus diagnostic efforts mainly if someone reports actual blisters or sores, just to rule FMD out.
And Bactrians?
For Bactrian camels, where they live in regions where FAD is already present, surveillance should probably just be integrated into the existing livestock programs there.
What about the tests themselves? Same tests, different interpretation.
Exactly. We use the same basic tools, PCR tests like RT-PCR, antigen ELISAs, antibody tests like the NSP ELISA. But what a positive result means can differ hugely.
How so?
In deer, finding viral RNA or NSP antibodies, that's highly significant. It points towards active circulation in a potential reservoir.
But in a dromedary camel?
Finding NSP antibodies might just mean it had one of those abortive exposures we talked about, not necessarily active transmission risk or epidemiological significance. You really need species-specific guidelines for interpreting those results.
So the bottom line is, managing FMD effectively now absolutely requires looking beyond the farm fence.
Yeah.
Wildlife health has to be part of the strategy. That's a huge shift.
It really is. And this comparison, it points towards key research priorities. Top of the list, maybe, developing effective oral bait vaccines for deer, OPVs.
Like they use for rabies in wildlife.
Exactly like that model. But FMD presents unique challenges. The vaccine needs to be stable in a bait. The bait needs to be attractive to deer. You need to get enough deer to eat it.
And you need special vaccines, right? Ones that let you tell vaccinated animals from infected ones.
Crucial point. They need to be Divia compatible, differentiating infected from vaccinated animals, so you can still do effective surveillance even when you're vaccinating. These would likely be new, next-generation vaccines, maybe using viral vectors.
That sounds like a huge long-term undertaking.
It is, but potentially transformative for managing FMD in areas with wildlife reservoirs.
And on the other side of the coin, the camelids.
The dromedary's natural resistance. That's a massive scientific opportunity.
How so?
If we could figure out the genetic and immunological basis for why they're so resistant, that knowledge could potentially unlock totally new ways to control FMD in all susceptible animals.
You mean like using that knowledge to help other animals resist FMD?
Potentially, yes. Maybe leading to new biotherapeutics, or even marker-assisted breeding programs to develop genetically resistant livestock. So if we could truly harness that dromedary resistance, we could be talking about fundamentally changing the game for FMD in cattle, sheep, pigs, moving beyond just reacting to outbreaks.
Absolutely. Imagine livestock that are inherently resistant. It shifts the whole paradigm, away from constant containment and culling towards a much more sustainable, built-in defense. It would be revolutionary for global animal health, for food security.
That's incredible potential.
And alongside the research, of course, policy needs to catch up. International standards, national rules. They need updating to reflect these very different risks posed by different species, especially clarifying the low risk from most camelids. And getting those species-specific diagnostic interpretation guidelines in place is vital.
It's so clear that understanding these very nuanced interactions is vital. It really transforms how we need to approach a disease that's such a constant, evolving threat. So here's a thought to leave you with. If we can unlock the genetic secrets of the dromedary camel, leading to a future where maybe our main livestock are naturally resistant to FMD, how might that fundamentally reshape global food security? How would it change animal health policies worldwide? Thank you for joining us on this deep dive into foot and mouth disease. We hope you gained some fascinating insights, maybe a few aha moments that will stick with you.